Okay, so again, this is another quite wordy one. I am going to start off with just drawing a diagram to sort of explain what's happening. It's not going to be accurate or anything like that. I'm just drawing it like this. So this man, he walks from A to B, so he's travelling from there to there. Okay, and then he travels from B to C. Okay, so that's what the first bit says. His displacement from A to B is 6i plus 4j. So that means this bit here must be 6i plus 4j. Okay, and then displacement from B to C is 5i minus 12j. Okay, so that's what it roughly looks like. So for part A, we're told that we need to find the magnitude of the displacement from A to C. So this is the quickest route that you can get from A to C. So I'm just going to draw it in red. So the first thing we need to do is find the vector of AC. Okay, and to do that, we just do the vector from A to B plus the vector from B to C. Okay, just like what you did in GCSE. I'm going to write them as column vectors just because it's easier for me to then add them together. So A to B is 6 and 4. 6 and 4, so just make sure you put the i's first and then you put the j's underneath. And then for BC is 5 and minus 12. Okay, so if we add those together, we'll get 11 and minus 8. Okay, or 11i minus 8j. Okay, but it says in the question it wants the magnitude, so that means again you're going to have to use the Pythagoras. So we're going to find the magnitude of AC. So we do the square root of 11 squared plus minus 8 squared. Now on a calculator, make sure you put brackets around the negative, otherwise it will keep it as negative 64, not positive. So we can type that in. So 11 squared plus minus 8 squared. And we get 13.6 kilometres. Okay, so make sure you read the question and it'll say what units it is. Okay. So that's part A. Part B, it wants the total distance that the man travelled, because obviously he didn't do the quick route of just going from straight A to C. So what we need to do is find, similar to what we did for the second part of part A, we need to find the magnitude from A to B, which is the distance, and then do the same thing from B to C, and then we can add those two together. So from A to B, well, I've written it the wrong way, but it doesn't make a difference. So it'd be square root of 4 squared plus 6 squared, which gives me 7.2. Okay, and then for B to C, we've got 5 and minus 12. Again, remember that's got to be squared. I'm pretty sure that's 13, but I will do it anyway. Yeah, 13. Okay, so their distances from those two separately. So the total distance is going to have to be those two added together. So 7.2 plus 13, which is 20.2 kilometres.